Alright, Appendix E, exceptional situations. U.S. Navy Underwater Cutting and Welding Manual. Appendix E, exceptional situations. E1, purpose. The appendix is intended for the covering of the cutting, the welding procedure, and equipment which may be used during an exceptional situation. Normally, procedure within Chapter 2 and 3 will be filed filed using authorized equipment tabulated in Table 4.4. However, when authorized equipment is not available, the situation requires immediate action. Hand alternate equipment and/or processes will likely be necessary. Such a predicament is known as an emergency or a special circumstance situation. Some examples of the terms emergency and special circumstances are defined as follows: ship in irons with wire in her screws drifting toward a lee shallow will be deemed an emergency. Salvage operation away from the normal logistic support would be deemed a special circumstance. A stricken submarine with life aboard would be deemed emergency. 411 discussion. Alternate equipment is defined commercially available and equipment which has not undergone the specific design, safety review, or test evaluation. Therefore, it is not identified in Table 4.4, including authorized for your Navy use or ANU list. Navy Sea Instruction 1056.0.2. Equipment has, however, been commercially proven safe and optional adequate. Authorization. Commanding officers are authorized to procure and use such equipment when these actions are deemed necessary for the accomplishment of the specific job. The authorization to become effective only of the duration, periodic emergency, special circumstance. In this situation, the commanding officer is accountable to ensure all operation safety procedures are strictly followed. E2, underwater cutting equipment. Arc water cutting. Water arc cutting is essential metalling process. Welding water is used to blow the molten metal out of the curve. Since the cutting is dependently solely on the melting action of the arc that is available. The power available up to 500 amps may be used. The process is limited. Using one manufacturer may be proper valuable when gouging out welds and cutting thin metal. Alright, E22, principle of operation. The process consists of the stripping and arc welding before the carbon graphite copper coated with a waterproof electrode workpiece of the metal is instantly transformed in the molten state, blown away from the high pressure jet of the water which exists. The torch in the outlet is located directly below the electrode opening in the torch. 2.3. Application. The process can be used with the following application. Can be used almost on all metals found in ship and underwater structures: to remove the defective fillet weld for the re-welding, and to cut the manner similar to the underwater arc cutting oxygen arc process. No, cutting material is excess of 1 inch. Well, this process is not practical. D. Cracked butt and seam welds will be grooved for wood weld repair. 2.4. Necessary equipment. The following equipment is required to be used in the arc water underwater and cutting process. Power. AC/DC. No AC/DC, but a DC welding generator capable of removing the constant open circuit voltage of 60 volts to 350 amps. This process calls for reverse polarity of the electrode positive. E242 water. The process required for the constant supply of seawater to freshwater supplied at the flow rate of 3.5 gallons per minute or 90 psi over the bottom pressure. Ship firemen will normally provide sufficient pressure for the process. 243 arc water torch. Arc water torch figure E1, electrically insulated with a completely waterproof except for the area with the electrode inserted within a small weld balance designed to minimize diver fatigue. 244 electrodes. Arc torch is designed especially formulated with a copper-coated waterproof electrode. The electrode's dimensions are 5/16 of an inch by 9 inches. Are completely waterproof except for the end of the which is inserted into the torch. The arc end of the specially waterproof which is removed with lightly tapping the electrode against the work. Alright, this shows your arc water torch assembly. Warning: the position of the ground in relation with the diver must be such that no time that the diver of the equipment can get between the ground and the electrode. The diver must avoid becoming part of the electrical circuit. Note: the thick gauntlet type glove in good condition worn over the pair of Playtex leg type gloves afford the best protection against electrical shock. They should be secured with the wrist and prevent slag from getting inside with the glove. And cold water wet suit gloves in good condition worn over the surgical gloves are all equally effective. Alright, 2.5. Arc water electrode cutting technique. Always before the conducting of the type of electrical cutting underwater, the ground cable must be attached with the workpiece. The diver can be either leave a surface of the cutting torch ground cable the cutting electrodes, or they can be lowered after the arrival of the work site. The first task is cleaning the spot with the ground clamp. The spot should be in a point with the front of the diver that should be scraped off with a wire brush, shiny clean for the driver's safety only. See clamps should be used with grounding clamps for the underwater cutting of the welding operation. Clamp must be firmly secured with a working piece of the cable should have sufficient slack to prevent it from being pulled loose. The diver may elect to lightly tack the weld and clamp the piece where it is possible for working loose. From time to time, as part of the cut progresses, the diver may reposition the ground clamp to avoid becoming part of the electrical circuit. 251 underwater preparations. Insert the electrode with the cullet opening until the bottom of the tight end of the cullet nut turns to start the hole of the electrical perconate with the surface to be cut. Play with the tip of the electrode to work with the cullet, the water on, then switch on, and then if necessary, and draw the electrode slightly and tap it again for the work to start the arc. 2511 cutting. For cutting, the torch should be held at a 75-degree angle with the water jet under the electrode carbon. Care must be taken to prevent the molten metal blowback. Once a hole is pierced, proceed along the intended line of the cutting using the saw motion. Holes can be pierced in the same manner enlarged using sawing motion. 2512 gouging. The depth of the groove will vary from the torch angle with the travel speed. Amperage pressure exerted with the electrode for the gouging and welding removal. The torch should be held at the 40 angle with the water jet with the under the electrode. The torch should be moved forward in specific speed sufficient to maintain the arc at the desired groove depth. The diver should not cut deeper than a quarter inch with a single path that will prevent the molten metal from being blown back to the driver. Warning. When the arc welder has been consumed with the 1.5 inches of the torch, to stop the cut and single with the switch and the water off, the force could changing the electrode make the torch in the cutting position with the tender signals. Switch off, then they tap the electrode twice to make sure the current is off. The safety precaution mandatory regardless of the type of the electrode. 26. Material consumption. Table E1 provided the planning of the purpose of the approximate range of the cutting through the various plates of thickness of the 3 inch and quarter inches and allowing that it should be made with a derived proficiency underwater conditions such as visibility, metal cleanliness, and current. Figure 2.7. Post-drive maintenance. After each use of the rinse with the torch, fresh water and dry it, and disassemble and inspect with the corrosion damage to the electrosis. Replace with the damage as applicable. All equipment should be thoroughly dried before starting. Secure the hose in the end caps with the tape with the clear of the debris. Store all equipment, including electrodes, in an oil-free environment. All right, E3, cutting underwater with a thermic lance or burn bars. Warning, the process produces a large quantity of the hydrogen gas. When combined with the oxygen, these concentrations are highly explosive due to the random explosion with some magnitude. Several of the divers engaged in salvage work have been killed using this process. Warning, thermic lances or burn bars are not used by divers underwater. Topside personnel performing the cutting below the waterline while divers in the water. However, during the situation where it's impossible to diver in a position with the cutting there when the cutting is accomplished for the surface, the thermatic lance may be used with extreme caution. Table E1 operating data cutting carbon steel. Thicknesses and metal thicknesses, inches a minute, and cut. Water over bottom pressure would be 90 to 100 psi, and your amperage range cutting is from 475 to 525. Stainless steel operating data is similar with the carbon steel non-ferrous metals such as bronze, brass, copper, and the content 80% can be cut with above the operation conditions. Warning, always wear protective clothing when using thermatic lance. Fully protect the suit with leather gloves and tinted face shield with a hard hat. And the caution, keep all thermatic lances materials away from oil and grease. Frequently during the salvage operation, continue to prevent self-saving, placing a diver in position for the cutting. Such a situation must be wrecked with a barge wrapped around a bridge pier with a strong current. With the situation when cutting from the surface from the torn twisted metal will require in as such. With the thermostatic line and the burn bar can be used to prevent cut. With some until other applications are to cut the holes in reinforced concrete. All right, E3-1, material description. The thermatic lance is a steel tube 10 feet long by 3/8 of an inch in the diameter, filled with the ferrous and non-ferrous wires or rods being held in place, crimp ends at the standing end of the tube of the holder of the connection with the oxygen hose. Due to the tremendous height produced with the tip within the oxygen, the forces through the tube of the thermatic lance will burn through almost anything. And readily oxygen-available, oxidable materials such as iron, steel, non-ferrous metals, rock, masonry, concrete can be burned through and melted and difficult to handle underwater because of the length of the consumable and numerous amount of oxygen. The burning time with one lance is about 6 minutes. The number of lances can be coupled together for the longer burning side, but extra length makes it extremely awkward to handle. Lance must be ignited by the outside source. For the cutting torch, the only way to extinguish the lance is to turn the oxygen off. Keep the flame from burning up the oxygen hose. It's necessary to secure the oxygen when the lance is consumed down to 1 foot length. Thermatic lance has a major drawback of a disadvantage, but it produces large quantities of the hydrogen cutting reaction. The hydrogen gas combined with the oxygen large pockets. There will be concentrated explosive gases. The concentrations are well within the flammability detonation limits of the gases and periodic with a random explosion of some magnitude. Obviously, there are some hazards connected with the use of the thermatic lance underwater because of the random explosion with large gas bubbles formed during operation. The explosion has killed a number of divers engaged in salvage work. E32 required equipment. The following lists are required equipment: thermatic lance holder, ball valve assembly, oxygen, 1 burn bar, requires 60 cubic feet of oxygen, 2 to 50 feet, 3/8 inch, 1/2 inch oxygen hose. Hose smaller than 3/8 inch diameter will not deliver sufficient oxygen. Two-stage high volume regulator, ignition equipment, oxyacetylene torch. 3-3 setup procedure. The following recommended setup of the procedure: connect the regulator to the oxygen source, connect the oxygen hose 3/8 1/2 inch to the regulator, connect the lance hole or in figure E2 with the hose, adjust the regulator to 80 to 120 psi, insert the lance into the holder, check for leaks, open gloves, ball valve on the holder, purge the lance and close the valve, ignite the oxygen torch and adjust the hottest flames. Light the endothermatic lance with the oxyacetylene torch and then adjust the oxygen. The lance will begin with a spark and will increase with more oxygen is applied. The thermatic lance is now ready for use. Place it against the workpiece being cut with the figure 2-3 and show the thermatic lance equipment set up. No, the thermatic lance will operate with the oxygen pressure for the 80 to 120 psi, but the pipe burns faster than the filler rods. Use with more pressure. If the filler rods burn much faster than the pipe, use less pressure. Alright, this shows a fitting 1.5 inch oxygen valve body screen and rubber insert end cap, thermatic lance holder assembly. Show figure E3 shows standard thermatic lance equipment setup. A is your thermatic insert torch holder. B is the thermatic lance holder. C is the connecting hose for the regulator for a regulator assembly. E, decoupling, attaching C to E with the unit consists of the coupling and hose assembly. And then E is the two-stage regulator capable of producing head pressure with at least 200 psi. And F is your supply of oxygen. E3-4, material consumption. One thermatic lance will penetrate 24 inches of the reinforced concrete producible with a hole of 2.5 inches hole with a diameter of 60 cubic feet with oxygen in 5 minutes. E4, the MAP gas cutting. Warning, acetylene is very unstable to pressure above 15 psi and is not used for underwater cutting. Alright, MAP gas. Gas cutting by the only oxygen fuel underwater cutting process approved by the Navy is used only with the oxy-R cutting equipment is not available. When this is absent of sufficient electrical power to conduct the oxy-R cutting. MAP gas is a mixture of the stabilized methyl acetylene propadiene. MAP gas cutting provided with a gas torch rather than cutting electrode. The technique with underwater cutting is exactly the oxygen and acetylene cutting topside. However, the greater deal more skill is required with the MAP gas process opposed to the oxy-R underwater cutting. Like the carry cable, the process uses useful ship salvage operations, especially in areas where the stringing along electrical power leads is difficult and also necessary equipment that can be carried in a small boat. The standard acetylene oxygen cutting torch is approved with the Navy use a spacer sleeve that is attached over the cutting tip with what it aids the diver in maintaining the proper standoff from the metal to be cut. Alright, E41, principle of operation. Principal cutting metal with the underwater with a gas torch, virtually same with the employed on the topside, except for the acetylene has been replaced with the MAP gas. Torch mixtures with the MAP gas over the oxygen will burn that generates sufficient heat to melt the metal to be cut. The smaller area with the metal with the heat with the molten metal and the oxygen directly to that point. The oxygen insert for the convergence of the molten metal pedal with the gases chemical state with simultaneously burning with the flame is angled slightly in order to preheat the metal with the head of the cut, allowing the cut to continue. Alright, E42. Equipment and material. The equipment generally required for the underwater MAP gas cutting listed in table 2 to E2 with the operating of the equipment should be used with the prior use should be examined, tested, and determined they operated properly. The entire assembly with some cylinder to torch, essentially one complete functional unit. The condition with the internal cleanliness of the repair with the regulators, gases, regulator gauges, manifold, torches, hoses, governing the overall operating efficiency. A fleck of dirt in the regulator top side can cause complete failure in depth. Table E2, equipment of the material requirements for underwater MAP gas cutting equipment. MAP gas oxygen supply, torch and tip spacer sleeve, torch tip cleaner, oxygen fuel supply hose, the proper fittings, high capacity 2-stage oxygen regulator, high capacity 2-stage fuel regulator, hand mechanical torch igniter, necessary tools and appropriate diving equipment. All right, E43, protective equipment. Mass gas cutting can be conducted underwater without special protective clothing and devices. E44, cylinder regulators. 8 to 10 220 cubic foot cylinders of the oxygen required for each of the M70 cylinders of the M MAP gas. All cylinders must be secured in an upright position when operating with extremely cold, when it may be necessary to warm the MAP gas bottles to maintain vapor pressure for the proper gas flow. This may be accomplished by a heated deck room or with warm water, or never heat the compressor gas cylinder with the open flame. These cylinders may also be warmed by placing them with the front of the radiators of the machinery, such as welding machine with the air compressors. High capacity two-stage regulators should be used on both oxygen and MAP gas cylinders, though the standard fuel regulator equipped with a high-pressure spring may be used only with the MAP gas cylinders. The hydrogen regulators, which are commercially available, may also be used with the MAP gas cylinders. However, the adapter is necessary if 15 psi over bottom pressure is required. To avoid blockage of the torch due to the dirt and foreign material entering the jet, it's important that flush the various components of the high-pressure gas before final connection of the flowing in is recommended setup of the procedure. Check the cylinder valve connection with the dirt particle to briefly open with the closing valve of the both oxygen and MAP gas cylinders. Preserve the manifold with a likely manner before connecting regulators. Also ensure that the pressure regulator thumb screw are backed out of the full release position when connecting the regulators into the cylinder. Alright, the hose and the connected with the regulator to the torch, leaving the end of the hose open. The 50-foot section with a 3/8 inch twin hose should be sufficient to work with a depth of 25 to 30 feet. However, the table the E3 with the information setting pressure selecting hose to avoid the excessive hose length since it causes the pressure to drop and get in the driver's way. Like all fuel gases, with the odorless nature of the chemical has been added to aid detecting by smell. E441, purging hose. The fuel oxygen lines should be purged and loading with the open end of the hose in one hand, pointing the head away from the open flame with the person on the other hand to slowly the open cylinder valves. When the valves are open, screw the thumb screw with the fuel regulator enough to purge the line with the blow out the any with the foreign material. The thumb screw should then be backed up to stop the flow. Repeat the procedure with the oxygen line. Our regular depth shows the depths in 10, 30, and 70. Minimum water temperature, minimum pressure for the hydrogen double state regulator, PSI gallons, minimum pressure for the acetylene single stage regulators. Alright, E45, underwater MAP gas cutting torches. The standard oxyacetylene oxygen cutting torch can be used with the cutting of the MAP gas underwater. Figure E4 shows the standard for the cutting of a torch with the underwater space or sleeve control for the oxygen MAP gas with the cutting with the oxygen control. For the FS stinger cutting tip of the torch must be attached with the hose with the carrying with the gas and torch clearly marked with the oxygen hose. The MAP gas hose will be connected with the proper gas passageways to within the torch. The additional safeguard for the threads and connect each of those are not compatible, since so that the air hose carries the MAP gas would not fit in the connection with the oxygen passage. An illustrated figure of E4 with a cutting two-piece with the standard piece pressure tip with a fine spline with a fits for the standard acetylene oxygen to cutting torch side collection with the proper tip side, but it depends on the thickness of the metal. Refer to table E4 with the proper side with the B with the various plate thickness for the cutting tip of the preheated perimeter with it equally divided into 18 to 26 mil spots. Slots just place the water more evenly with 8-hole standard pressure tip. For this reason, the cutting tip of the pressure faster than give the quicker start, but especially recommended with the cutting to be done with the tip of spacer sleeve. Alright, E4 shows the recommended cutting tip sizes. The FS is number 52 for 1/4 inch to 1 inch, number 46 for 1/4 inch to 2 3/4 inch, 3 to 4 inches for number 42, 6 to 5, 3 and 6 to 5, number 6 to 5 inches, the number 38 stinger, number 4 for the 1/4 inch to 1 inch, number 5 for the 1/4 inch, 1 1/4 inch to 2 3/4 inch, 3 to 4 inches, number 6, and 6 to 5 inch, number 6. The spacer sleeve shown in figure E4 clamp for the overcutting of the tip for the cutting of the tip of the proper distance from the work, which should be minimized to 3/16 of an inch maximum. The 1/4 inch for the cutting tip of the sleeve should also be perforated to allow the water circulate around the cutting tip. After the tip and spacer sleeve of the sheave of the flame should be lit with adjustment necessary for the set with the recommended regulated pressure for the flame burning with the cutting oxygen valve with the wide open. Work should be done at once that when any cylinder pressure drops below the recommended operating pressure, when the preheat produce the mixture of the MAP gas oxygen supplies heat at the start, The cut maintained the cutting temperature. The central oxygen jet accomplished for the actual cutting oxidizers blowing out an arrow bearing of the metal to produce the curve. The gas control is typically incorporated with the cutting torch as shown in figure E4, where the torch is not connected with the hose. The working pressure must be then set before setting with the cutting tip. The torch each with each gas separately. Alright, this shows your standard surface cutting torch with the underwater sleeve. Show the torch. 1/8 of an inch, brass, silver, bronze, copper, 5/16, 3/8 of an inch, 3/8 of an inch drill, 10/32 set screw, 1 15/16, 1/38 of an inch, 5/8 of an inch, 6 17 of an inch, 650, 780, 7/8. Alright, your torch igniter. A hand mechanical igniter should be used with the lighting of the torch. A simple tube is safer than the electrical igniter is equally effective. After the steel has been pierced, cutting the procedure approximately the same speed as does above the water. The popping sound of the herd, other than those made with a hot slag forming the water, adds a small amount of pre-hot oxygen heat to the flame. The same procedure applied with the edge of the start. It is important to recall the ocean with a giant heat sink that has cooling the action at least 40 times greater than the air. Therefore, the light thickness of the steel will require much preheating as the heavy thickness because of the rapid heat transfer over the lighter steel. E46 ignition of the torch above water. Note: before igniting the cutting torch, review the safety procedures in Appendix D. E461 preparation. The FS52 and Singer 4 cutting tip recommended with the underwater cutting material of the 1 inch thick. The seal seated the cutting tip with the high capacity torch with the cutting tip spacer sleeve for 1/4 inch coupling distance. Set the MAP gas regulator to 20 psi gauge. Oxygen regulator pressure to 60 psi gauge. Once the work site is maintained, the MAP gas oxygen pressure according to table E5. Ignition. The following procedures are used when igniting a cutting torch in the air. Open the fuel valve with approximately 1/4 inch, 1/4 turn. Crack the preheat oxygen valve. Light the torch with a spark lighter. Bring the flame up to the maximum. Open the preheat oxygen valve, adding the fuel with the stable preheat with it maintained with the tip of the end of the fuel valve nearly wide open. Alright, E. The flame should be burning with a high volume velocity of the atmosphere, but they should be some adjust to the left of the fuel with the pressure preheating the oxygen valve, or the diver can make a last minute adjustment as desired to the work depth. Preheat flame should be adjusted correctly before the torch is lowered to the diver. The flame has been adjusted above the surface of the torch, approximately 10 inches below the surface of the water. Opening the cutting oxygen valve wide open. The flame plays around with the surface of the add preheating oxygen until the flame disappears. This torch was now ready to be lowered to the diver. Table E3 shows the recommended pressure setting for the hose and selection of the chart, the depth of the feet salt water PSI, and then your MAP gas pressure PSI, hose diameter, inch, and hose length. Show the oxygen pressure PSI gauge and plate thickness, depth of feet salt water pressure PSI, 1/4 inch, 1 inch PSI, 1/4 inch, 2 3/4 inch PSI, 3 to 4 inch PSI, 5 to 6 PSI, hose diameter, inches, hose and length. E47 lowering the ignited torch. If the ignited torch may be lowered at the working location one of two ways: carrying the torch below the moderate shallow depths on the easily accessible location. Ignited the torch may be lowered. May carried below the hand. The diver should be prepared to make adjustment to the flame compensate with increased hydrostatic pressure during descent. Lowering the ignited torch, the shallow depth of the location where the absolute center of the flame can be kept clear of all the hoses lined. The diver dressed in a helmet, other equipment, and other personnel. The ignited torch may be lowered directly to the point within the reach of the diver. Never load the ignited torch until it is certain that the diver is ready to watching for it and is in clear in such a position with the torch flame that can not possibly strike his helmet or suit or umbilical. It is responsible for the diver to tendency with the correct pressure for the maintain with the regulators for the job that has been completed. The diver should shut off the MAP gas valve first from the relief of the oxygen trigger. However, let the preheat oxygen blow until the torch is removed from the water. This will keep the preheat parts from being clogged with the foreign material. Clean the torch tips, suspect with the clogging have occurred. E48 underwater cutting. The cutting may be started with the edge of the plate as shown in figure E5. E481 starting the cut at the edge of the plate. Starting the cut at the edge of the plate proceeds as follows. Hold the torch head over the corner of the plate so that the preheat flames can heat the spot of the edge, and the spark flies from the steel will indicate that the metal is hot enough to start the cut. Start the cut pressure on the cutting lever to direct the cutting jet onto the hot spot. Better result that you can obtain by opening the cutting jet about halfway for a few seconds of the start. E482 starting the cut on the central portion of the plate. Cut may be started in the middle of the flat plate by blowing through the recommended procedure as valve. Hold the torch one spot with the plate until the brought to heat in the figure E6 show the torch position starting cut with the middle of the flat horizontal plate. Turn on the cutting jet gradually, same time raising the torch head slightly to the slag will not blow back on the tip. The two motions should be simultaneously. This shows the torch hit the preheating flame orifice of the steel plate, the spacer sleeve, and the preheated area. Your torch hit oxygen cutting spacer sleeve, preheating flame, and steel plate, slag, and seam advancing in the cut, starting the cut with the edge of the plate. A is hold the torch with the tip at one spot until the plate is heated. B is turning the cutting edge gradually at the same time with raising the tilting the torch so that the slag will not blow back into the tip. C, after the hole is pierced through the plate, proceed with the cutting in the normal manner. E483 advanced cutting. The cutting is advanced motion of the torch steady with a uniform rate of speed along with the line cut fast enough to keep the cutting going, but slow enough to cut completely through the metal when the torch is advanced. If too slow, the steel will cut below the ignition temperature of the cutting and the action will stop. The diver has the lost cut. Last the cut will have the restart of the cutting action. The torch is advanced rapidly with the cut will not be completely thoroughly through the skip spot for the hanger will be very hard to cut, and when the cutting has been lost, it may be restarted with the going back 1/4 half inch to 3/4 inch. Start with the new curve. One side of the old cut as shown figure E7, but the purpose of this is to be sure that the cut is complete. Shift the direction of the cut, the steel plate, the curve, the start of the new cut, the original end of the cut, and the line of cut. Underwater cutting, welding. Caution, do not do the flammability, the toxicity of fumes of the waterproofing compounds. Waterproofing must be conducted as well to ventilate space clear of open flames and spark-producing machinery. When commercially produced with waterproof wet welding electrodes are not available, surface welding electrodes can be used as waterproof as above the water. Can be used if waterproofed. Some of the water electrodes will give satisfactory performance underwater if the properly prepared and dispositing skill driver. The electrodes enlisted in table E6 are suitable for on-site waterproof in the position of welding underwater with the E6 13, E70 14, E70 16 stainless steel electrodes 1/8 of an inch diameter and are suitable. Alright, E5, waterproofing surface electrodes. Unlike the commercial manufactured wet welding electrodes necessary with waterproof flux and coating with the surface of the welding rounds, so they accomplish for the dipping of the electrode in one suitable waterproofing solution in the table E6 for the 1-2 dips that may be required depending on the viscosity of the waterproof of the material. Be sure to complete the cover over the flux coating. One of the 2 dips that they require to cover the water the proof of the cutting and an adequate water force in the interstice will turn the steam when the arc is struck and will blow off the coating. The water coatings must be thoroughly dry before applying additional coats. Also, before they are used, the grip ends of the electrode should be cleaned to prevent the waterproof of the material from interfering with electrode contact between the electrodes and the hole. The desirable send of the diver only a few electrodes at a time, since the waterproof project protects the electrode covering with a limited amount of the time. E6, those are the welding electrodes suitable for the welding. You have your carbon steel E70, E70 16, E70 18, E60 13, American Welding Society A51. Your 1/8 of an inch, 532, 3/16 of an inch, E309, E310, E312, stainless steel, American Welding Side AW54. 1/8 of an inch, 532 of an inch, ENICR F2, ENICR F3, ENICR MO3, high nickel American Welding Society AWS1. Waterproofing materials, epoxy 152 mil P2441. LELAC 30L2093, non-petroleum based clear polyurethane. Alright, E52, preparation underwater shield metal arc welding. Standard electrode holder design surface may be used when underwater holders are not available, but only in an extreme situation. It must be realized that the holders are never intended to be used underwater, but therefore they are not adequate insulated. Importance of the fully insulating with the current carrying parts of it cannot be overemphasized. The table E7 amper setting depths of 50 feet salt water. When preparing underwater welding operations, several factors must be considered before welding actually begins. Adequate electrode operation must be made with a lack of attention to detail within here and will result in the wasted diving time. For the best result, follow the guidelines below. Avoid handling with flux coating with the fingers before dipping the process. E70 14, E70 16 electrodes should be removed from their containers, placed into an oven. The electrodes should be heated with 300 degrees Fahrenheit, held in temperature for about 4 hours. The oven temperature should be reduced to 150 degrees. The electrodes must remain in the oven until the dipping operation takes place. It's important that the work is to be accomplished area with low humidity, mixing the waterproof according to the manufacturer instruction for the clean container, attaching handing clip for the bare metal above the end of the electrode made dipping. The suitable clip for the fashion using an obligator clip for the hole and drilled at one end with the S-hook made from the small wire. Dip water electrodes vertically in the waterproof solution. Wait until no more gas bubbles generated electrode appear with the dipping container. With only remove the electrode from the container. The ensure with the sound ununiform waterproof coating with a flux covering. Typically, the electrode once or twice the desired, covering all the flux coating with each of the time, and the dipping more than one electrode at a time. Do not allow the surface to touch one or the other. Hand electrode vertically is warm with the dry end. This allows the extremely waterproof and absorb the flux coating to run off evenly with a form of slight bubble. The electrode tip will leave with the bubble attached. This will move the remove the diver strike arc. Allow the electrode to fully dry before re-dipping. Follow the same procedure with the E3008 and the E310 electrodes. Do not heat the E613 electrodes prior to dipping. Do so will dry out the water-based flux adhesive, rendering the flux useless. Alright, these are recommended ampere setting for the wet welding depths of 50 feet salt water, E613, E17, E7016, E7014, E3XX, high nickel sizes, horizontal amps, vertical amps, and overhead amps and arc voltage. Alright, waterproof the compounds dry time with the various minutes with several days. Never under any circumstances put on waterproof electrodes in warm oven. The coating process should produce the hard and uniform surface without length and blister. But the coating should be not dissolve or deteriorate when exposed in salt water. This exposure the cause of usually incorporated waterproof techniques. E6, loss of voice communication. While operating under the guidelines of the chapter of contingency planning should be adopted, the loss of the voice communication between the tender and the diver. Supervisors should establish a clear line pull of the command system when returning configuration, switch on and switch off. The E7 friction stud welder. Historically, friction welders may have been restricted large heavy the equipment permanently installed with the workshop and stud attachment involved with the electrical process for the power source of the cable, delivering several hundred amps with a three-phase power supply. The C-stud portable friction welder, figure E8, is a lightweight and handheld air tool with attaching various studs as metals and other materials. The E71 principle of operation friction welding procedure produced the weld may be the heat generated between the rotating stud and the fixed metal, with the heat generated with the junction of the rubbing component with allow for the interface of the metal to become plastic flow or radially from the point of the contact, same time removing the surface of the contaminants. When the interference has been achieved with a clean high temperature condition with the two components of the floors together, the rotation stop at the point with the bond with consolidated. All of this occurs with the seconds without protective atmosphere gas fluxes. Welding time is vary about 1 to 4 seconds, 40 seconds depending on the material with the stud side with the metallurgical properties involved with the ideal tool installed with the patches. Alright, E72 advantage. The following advantages are associated with the C-stud. The C-stud is pneumatically powered independent high voltage power up supplies. B, minimum surface penetration required for the process, the unaffected for the main surface of contamination. C, with the operation technique is very simple and readily mastered. D, only seconds are required to achieve the weld. E, there are considerable metallurgical advantages with you with the method of the defects normally associated with welded metal. Such porosity, slag, inclusion, cracking as arising for the air regulator is not possible, therefore rapid solidification can occur. E73 equipment requirements. The term handheld for the RU to describe the unit, but the term was misleading with the unit merely carried to the job site by hand. To operate the C-stud, the friction welder must be locked in place by one variety of the clamps, which are supplied with the unit. The either mechanical, electromagnetic vacuum will hold the unit onto the variety of surfaces such as steel, ferrous, and non-ferrous concrete or wood. E731 equipment detail. The equipment details are as follows: welding gun C-stud S1004, weight in air 24.2 pounds, weight in water 13.2 pounds, required air supply 150 SCFMs at 125 psi, stud capacity diameter 3/16 of an inch, 5/8 of an inch, length 3/8 of an inch to 7.9 inches. Studs are available along strength carbon steel, stainless steel, commercial quality aluminum. These clamps are reaction clamps designed to quickly deployment and release. Are described as follows: magnetic power required 35 volt DC, pulling force 3,520 pounds squared. Vacuum air reductor system, pulling force 5,280 pounds squared. Mechanical beam clamps and pipe clamps. Sorry, the note 2 means based on manufacturer data. Note 1 means air requires welding gun working depth. This shows your friction stud welder, the C stud. And that went on to the glossary. We don't need to cover that. And then the index, and that concludes the reading of the U.S. Navy Underwater Cutting Welding Manual, April 1st, 1989.